Hello and welcome to my talk, JUnit5 Custom Test Engines. My name is Sven Ruppert and I'm developer advocate at JFrog, and they're specialized for DevSecOps. Today we want to see how to create your own test engine for JUnit5. That means in the beginning we will have a short introduction about the possibilities of the default test engine from JUnit5. After this I will show you how to test your test engine so that you are able to test your own test engine later, and how to start a custom test engine. After this we will have a short overview about the basic structure of test engines, and then how to define a test so that a developer can write his first test for your custom test engine, then how to execute test plans, and in the end, custom test engines, some ideas and possibilities what you could do with custom test engines and why this will help you. First of all, I want to have some ideas or some refreshments about what is a test scope and how this is organized in JUnit5. Here, let's see, we have global preparation. These are the yellow bars here in my slides. Means that something should be started or prepared before you start executing your test engine. The next thing is you have preparations just for your single test as well. So for every test, for example, you're ramping up a software container, or you're ramping up some demo data or whatever, and then you're executing this test, and in the end, after this test, doesn't matter if it is successful or if it has failed, it should redo or undo all the preparations you have done for the test. And after all tests, or after executing the test plan, the whole test plan, you want to make sure that all resources you allocated in the beginning are deallocated again. So in total you have some life cycles, and quite often you have to create resources, destroy resources, and all this stuff around the test you want to execute. Talking about this one means that every test will have its own context. The context itself means that you want to share some information between the ramp up phase and the ramp down phase of a JUnit test. For example, you're starting a servlet container, you're running a test, and then you want to destroy exactly this instance of the servlet container. And now we have a challenge. First of all, every context of a test itself should be isolated so that no context is shared between different tests if it is not necessary or you explicitly say you want to share. And this means that you have a context that is going over all tests, for example, over your whole test plan as well. Different borders or scopes could be all tests in one class, all tests in one package, whatever a test scope can be for you. In the end, you're talking about a hierarchy of context, so that if something will be stored there, it must be accessible inside the context but not outside. Not below, maybe not, it depends on your needs, and maybe not outside or above this context. So the main thing here is that assume that something will happen during the initialization phase, then mostly it's easy to cover, because if something is going wrong, the servlet container, for example, is not started, the test will fail because the resource is just not available. But think about something that will happen during the test deactivation phase. So for example, if you want to remove all stuff from the context to make a space or make it available for the next test. This means that if you have exceptions, or if you have something that's going wrong inside your context or inside your context management during the ramp down phase, this could lead to really bad behaviors and wrong test results. So one thing is, a preparation for tests must be very fast, because the really important time is the test itself. And all the preparation before and after, or the ramp down phase, is just technical costs. The next thing, it is quite easy if everything is very symmetric. Means for this test I have to ramp down this service, and after this test I have to ramp down it again. So up, test, down. But what would happen if you have it unsymmetric. So if you're ramping down something and then you have to do several tests and then ramping down later. Even this is symmetric if you're really doing it over a bunch of tests that are in the same scope or whatever. But sometimes you have asymmetric things, and this could be a challenge. One question is how to deal with exceptions. For example, you want to ramp down a servlet container, there is an exception, and the servlet container you ramped up is still running. So how to deal with these exceptions? What do you want to do with the test plan? Do you want to fail the whole test plan or just a part of the test plan? So dealing with exceptions is one of the really important things with JUnit test engines. And last but not least, every test can have its own preparation. So the declaration and how to deal with this context and ramping up and ramping down should be in a way that it is dynamic or customizable very easily, but not so that you have to declare again and again the same stuff for the same kind of test. So there is a challenge that you are doing it flexible enough, but not too repetitive. If you have now this single test, then the next question is how to deal with test groups. For example, you have this context and then you have different test groups, and these test groups should it be isolated? Yes, no. And if it is isolated, in which way is this isolated, or do you have the possibility to share information between test groups? Okay, and if you have different test groups and you have the decision done if information could be shared between different test groups, you can think about test engines as the next one that is holding a bunch of tests or a bunch of test groups. So with JUnit5, it's possible to have a bunch of test engines during the same run. So it's not necessary to decide you want to run only one test engine. No, you can have multiple test engines in one test run. How this is done and ramped up, we will see later. But as short recap, we have this single test, a single unit of something must be done with individual preparations. You have this clustered in some kind of groups with shared resources or shared preparations and ramp downs. And then you have different groups you can define, and then you have inside or around these groups or bunch of groups you can have dedicated test engines. This is the main structure that is introduced by JUnit5. Some parts of this was already existing in JUnit4. But if we have this in mind, we have now different possibilities. We have to think in general how to define tests, how to define groups, how to deal with context and preparations, and how to deal with different test engines, because everything together will give you the full power of how to deal with the JUnit5 environment. This graphic I'm showing right now is not from me, it's from, I think it was from the original documentation of JUnit5, but it will show you some very interesting things. One thing is, for example, that you have in JUnit5 the possibility to run the old vintage engine. It means the possibility to run nearly all JUnit4 tests. That means for migration purpose, you can just hold your old JUnit4 test and run them inside JUnit5. This is a good idea because if you have to think about migrating from JUnit4 to JUnit5 or from JUnit4 to your custom test engine in JUnit5, this will give you the possibility to play a little bit with the timeline or with investment line. So just have it in mind. There are some things that are not really running with JUnit4, but you have to check it for every single JUnit5 subversion because this is changing, and then have that in mind during your plannings. The next thing is the new test engine. The default test engine is called Jupyter, and here we have a very generic, a very broad test engine that fits nearly to 80 or 90% of all needs you have. And it's always a good advice before you're writing your own test engine, just check if you can do the same stuff with the default Jupyter engine, because then you have a managed or maintained test engine already, and you don't have to do it by yourself. And then you can go with third-party plugins on top of this platform. So all these test engines are running on top of the platform. And then we have a tiny beast here below. It means this tiny bubble here with IDEs and build tools. First of all, I thought, this is just to mention all this stuff. But if you're looking a little bit more in detail to this tiny thing, you will see that, or if you're analyzing the behavior of these different tools, you will see that the behavior between Maven and Gradle, even if you're running the same JUnit5 version with the same amount of tests, is a little bit different, because there are changes or difference in the way they are managing class paths and the class loading. And this is sometimes not nice, because you have little different behavior, and the same is with Eclipse and IntelliJ and all this stuff. You have different, slightly different behavior, even if you're using the same source code. And what this means, I will show you on how you can remove this one with your custom engine, custom test engine like this. This I will show you later. Okay, if you're looking at the general purpose weapon here, this general purpose test engine, we have this global preparations, subject of test, we have this context and the global context inside a test group, and it means we have now different things to declare. For example, how to declare test, how to extend or customize the lifecycle as well, and then how to deal with the extension context. The JUnit5 intro. If you want to write a test, the only thing that is needed, okay, you need the dependencies for sure, but then you just need the annotation add test. And then you have more or less a functional test. That's it. So to declare a test is just done by adding an annotation. So it's part of the source code itself. If you want to extend the lifecycle, you have different possibilities. And one thing is, or the lifecycle itself, you have inside the documentation the lifecycle and the lifecycle steps well defined, but here check again the documentation for exactly your JUnit5 version, because there are difference in between this tiny version differences. But in general, it's like you have these callbacks. Here in the slides, I'm showing you the before each callback and after each callback. So before every test and after every test. And to customize this one, you just have to create a class. Then think about the lifecycle steps you want to extend or customize, where you want to hook in. And then you're implementing these functional interfaces before each callback, for example, or and after each callback. And then you see inside this method declaration that you will get an extension context. Inside this extension context, you will find all the information you need about the invocation, and this is a place where you're pushing a state so that you can share information between the before each callback and the after each callback. What you definitely never should do is storing something in the test class itself in this instance, because the platform doesn't make sure that you're dealing with the same instance if it is not invoked a few times, and so on and so on. So if you have to share something, go over this context. That's it. To use your extension, you have to go to your class, your test class, and just annotate it with extend with, and then the class declaration. And after this, the lifecycle is activated for exactly this class and all tests inside this class. Okay, the next one is, I have now two extensions. And if I have two extensions and I'm going to my test class and extending 2 times, for example here with my extension A and my extension B, then both implementations are active to customize this lifecycle. One thing that's very important here is there a difference if you're writing extends with A and then extends with B compared to extends with B and then extends to A? And the answer is yes. So the order matters definitely here. If you're extending first with B and then with A, then you will have the following lifecycle. First, everything before all from B will be done. Then before all from A will be done. After this, before each B, before each R, the test. After each A, after each B, then after all A, and then after all B. So what's done is it goes from the outside to the inside and then reverse to out of the test. That's very good because it solves a lot of challenges we had with JUnit4. Just have it in mind. So the order definitely matters. If you don't want to add so many extensions, you have the possibility to use the extensions annotation. Then you can create a composition of all your extensions, and then you can use this composition of extensions at your test class as well. So what I would do is the tiny extensions are technical extensions, for example, ramp up servlet container, doing ramping up database and all this stuff, and then just build compositions with more business-like wordings, for example, ramping up environment or whatever, and build this composite annotations. That's it. So, talking a little bit about the context itself, because we need this one later to store or to share information between tests. You will get this instance of extension context, and here you have to deal with stores, and the stores are more or less a store is nothing different, or it's a hash map. It's a hash map. So the store itself, you're asking the store, please give me the instance of the store with the name ABC. This should be a constant shared in your application so that you don't have refactoring issues. And then you have a hash map with a name or an entity of a hash map, a dedicated entity of a hash map. And then you can just push data in, push data out. It's just a key value store. And here I'm just using a key that I'm declaring like a final like a final string or as a final string to make sure that I'm using the ID autocompletion stuff and all this stuff. So I'm putting stuff in my store, I'm executing the test, and after this one I will get exactly the same extension. I'm taking the same store, I'm grabbing out the instance, and then, for example, destroying the servlet container. So before the test, I'm creating the servlet container, pushing it to the context. After the test, I'm grabbing it out and destroying it. That's it. So this is quite easy. So if I want to have my own instance injected, because there's quite easy dependency injection implemented in JUnit5, you can just declare it here, so to say at test, and then you're writing down, or you're writing inside the method signature the classes and variables you need. And now JUnit5 needs to understand this one. For this you have this parameter resolver. This parameter resolver is more or less something that will hook inside the lifecycle automatically. So they are scanning the class path and then they're activating this parameter resolver. You can do it manually, or you can use this with this auto scanning feature. And you have to implement 2 methods. One method is a support param. This is just check if the type that is now inside this method signature is exactly what you want to handle. And then resolve param is just how to create or how to get this instance. And with this, you first get the support param invoked, and then you say, yes, it is a type I want to handle, or no. And if this is done, the second method will be called later the resolve param. You will get this extension context. So if you know that there's something inside this extension context already shared or stored, you can make use of this one and then just create the instance. Here it's just a new constructor, but you are completely free in technologies you want to use. Okay, now you are able to create on the fly things you are injecting into the test. To activate this one, you can do it on class level or on method level. Here I'm just showing it on method level. I'm extending with this param resolver I just created. And this means for this dedicated method, I have the possibility to get this instance of type demo injected on method level or on class level, and then this is available. Okay, why I'm talking about this that's already existing? Well, we need all this, for example, to test our own test engines. If I'm writing a test engine, it makes sense to write tests for my test engine to make sure that the implementation is doing exactly what I'm expecting. So we are writing tests for our test engine, means we are using the vintage engine. This is highly recommended because then you have this basic test engine that is validating the behavior of your custom test engine. It's this chicken or egg question. So how to test a test engine? First of all, we need a way to test a new test engine. So how to do this one. And for this, we will just create an existing test engine first. So how to ramp it up, how to test it, and then we will see how to create our own one. For example, I'm creating a demo test class, and here I have 3 tests. One test is just doing nothing. One test, and with this doing nothing means implicitly it is a positive test. The next one, test 2, it's just throwing exception, and explicit a runtime exception with a dedicated message. And the last one is a disable test. To have access to this toolkit, you need this dependency org JUnit Platform, and then the artifact ID is JUnit Platform test kit for the dedicated version you are using. And don't forget, just put it into scope of type test, so that's not delivered accidentally. So here I have my demo class, I have a positive one, I have one test failing, and I have one test that is disabled. It means in general I have 2 tests started, 1 test disabled, 1 positive, and 1 negative one. If I now start the test engine, here I have my engine test kit. Inside my engine test kit, or with this one, I have a bunch of methods to invoke or to handle this one. They really love the static methods. So I just use the method engine, and I'm using a name for it, the engine ID. What an engine ID is, we will cover a little bit later. And then I define the amount of input class, or the amount of tests. You can say just go to this package and take everything, or to the class path and grab everything. But if I want to have a dedicated test for one test engine, it makes sense that I'm just using explicit one test that I want to use as input for my test engine. And here what I'm doing is I'm invoking the selectors method and selecting a class, and here in our case the demo test class itself. Then I'm executing the whole stuff, then I'm grabbing the tests out of it, and then I start analyzing the result. Here what I'm doing is I'm checking the status, and here I'm just checking status.started2. Yes, I have 2 started, the positive one and the failing one. Succeeded 1, yes. Skipped 1, yes, it was this with this disabled one. And then failed 1, this was a runtime exception. What I checked right now is just if the general behavior was okay. So I have here this declare test, and everything happened in the way I thought it should be. After this, I can just go a little bit more detail and check, for example, the failed test a little bit more. Here, just as a recap, the test 2 was throwing a runtime exception with I must fail message. So what I'm doing here is I'm starting the engine again. I'm selecting not the whole class, I'm just selecting the method inside the class, my test class. It means select method, demo test class, and then I need the name of the method. The bad thing here is that's not really refactoring safe because I have to deal with plain strings in the end. But well, just have it in mind, if you're declaring this one, make it refactoring safe declared in static fields so that you can reference it a few times. Then I'm executing exactly this tiny one test and just checking here, for example, I have one failed test. Yes, I just put one test in. And then I can say, please check if this one finished with an exception. Yes. The exception was of instance runtime exception. Yes. And then I can check if the method was something like, and here I'm just have the plain string that I'm using during the test declaration. So it makes sense not only to check the statistics, it makes sense to check the failed tests and all this stuff very well, because how to deal with failed tests is a critical thing for custom test engines. How to start a test engine. After we know now how to test a test engine, it makes sense to understand how to ramp up the default test engine and then the own one. The test engine itself will discover the tests. So what is the amount of input or the amount of test cases for me? Then you have to prepare the launcher. You're creating the test plan itself. The test plan is a tree with information about in which order I should execute what type of text with and what is the input information I have for this test. After this, I can register a few listeners, for example, to create statistics, to collect runtime metrics, to collect whatever. So everything I can just grab during the execution of the test plan itself. Then I'm executing the launcher. I'm just saying go. And after this, I'm grabbing the result out of this engine and analyzing or dealing with the result itself. This is a little bit more source code. It means here I have this request. I'm building with selectors the amount of input tests. Here I'm using this reflection helper methods from the JUnit team itself. So it's a good advice to use this one and don't create this by yourself. It's there are a lot of work in this stuff, so don't do it by yourself again. Here I'm selecting a package. For example, my personal behavior is that I'm using as prefix JUnit dot and then original package name, so that, for example, some configurations are easier for me, but you will have your own naming schema. So select the packages or the class paths, whatever is the input, and then build the request itself. After this, create all the instance of the listeners you want to have. There is one default listener, for example, the summary generating listener. Yeah, use it or whatever. Don't use it if you don't need this overview. Then create the launcher config. You have this builder pattern here to create it. And here it's important that you are disabling a lot of automatic features, all this auto configuration, auto resolving and all this stuff, so that you have a very defined and clear, precise input of what you're doing. For example, here this test engine auto registration, just kill it so that not additional test engines are started. Then this auto registration for this execution listeners, just make sure that you are just dealing with your listeners you really want to have. And then you just need an instance of the test engine, and this is just done by new Jupyter test engine. That's it. Maybe your test engine will need some other init process, but a test engine itself is just an instance of a class in core JUnit5. And then adding the listeners, and then you have the configuration to deal with. After this, going to the factory, providing the config and creating the launcher itself. Then discover. So just see what is a test plan. The test plan is now something static It's a tree of all this information with notes about what kind of test, in which order, and so on. Then you're executing those, and then you're consuming, for example, the summary. So this is just copy-paste code, so it's really recommended just to do it in the same way and then maybe tweak it a little bit for your needs. But there is no support from the JUnit5 team so far to get rid of this boilerplate code. But here it is. So the basic structure of a test engine. Coming now to the test engine itself. What do you need? I want to show how to create the first or the minimum test engine itself. And what we want to do, we are not dealing with test discovery right now, so we are just declaring a test plan by ourselves to understand the structure. Then have in mind that the production code inside your project is the test engine itself, so don't put this one in the test source code path, put it in your production code path. Then the test code is the test for the test engine, for sure. And then we are testing our own tiny implementation with the Jupyter test engine. So to have access to this one, or to the basic implementation, so that you can deal with some basic implementations or support utilities, just add the Junit Platform engine inside your compile scope, and the platform comments in your compile code as well in the scope compile. So now we have the basic functionality that we can use to build stuff on top of the platform and to build our own test engine. And then we need some platform launcher. This one we need as well, and this in compile scope as well, because we want to write integration tests for our own test engine. So how to write the first own test engine? If I want to write a test engine, just implement test engine. That's it. You have to create you have to implement a few things. The first method is getID. GetID is just like an identifier. Make sure that you're not using the same ID for different test engines. That's it. So it's not a good idea to call your test engine Jupyter. The next one is a discovery method. The discovery method we will cover a little bit later. Here we are just creating one node because our test plan right now is just one node. There are no tests, no discovery. We will come back to this one later. But what we need is you have this engine descriptor. A descriptor is just one node in your test plan, or one kind of node in your tree. And you have this engine ID as an identifier, and then a display name. This display name is just a logical name that you will see inside the log files or on command line output and all this stuff. Sometimes, just make sure that there's a nice name someone can understand. Then we have the read node. This is the return type from the discovery method, so to identify what is a whole test plan. And then we have the execution itself. And this is all. So the execution is just, you have now the engine, the instance of the engine, you have the execute this listeners, because during the execution plan you can just say listener A triggered, listener B triggered, and all this stuff. And then what you should do is just, before you're going from one level to the next level inside your execution plan, just say to this listener, for example, I start executing now this level, and after this one is done, I'm done with this, and this was a success, yes or no. So in total, you have this engine, you're grabbing all children you get from this one, and for every child, we are just invoking now for that listener, start it, stop it, say it is successful, and if you have done this for all children, say the whole plan is successful, executed, and that's it. So this one, what you see here with this going from one layer to the next one inside the tree, is more or less a basic behavior of a test engine, and then you have to say yes and no for every layer. I'm starting with my work now, the work is done, and it was successful, yes or no. This is more or less a basic structure we have to follow. If you're doing this one, you will see output on command line. For example, we found one container. Yeah, we just started one. We started one. Yes, we have one successfully. Yeah, we just used always a successful method. And we have no test, we have no failed test, we have no and so on, because we just created a root node for the whole test plan. So from this one, the next question is how to activate this test engine. So, and how to declare test. So these two questions we have now. First of all, I want to see how to declare, or what is a possibility to declare a test. You have different ways of declaring a test, and it's really up to you how to do it. Here I'm showing you just how to do it inside the source code with annotations, but feel free and imagine that you can do everything. You can just go to one endpoint and just get a bunch of test instructions. So it could be a file, it could be a REST endpoint, it could be inside an database, it could be everything. So it's just one way of defining a test. And here I'm using just the traditional or the most common way to create an annotation to declare a test inside Java. Okay, what I want to do, I want to find all tests that are annotated with @nanotest, so my annotation. I want to execute all these discovered tests. The IDE should be already able to execute it with right-click and execute method, or execute and package and all this stuff. And with Maven, I want to do exactly the same. So I want to have Maven test, and it should execute all this stuff. If I have done this, I'm sure everything is fine for the beginning. So what I'm doing here is I'm creating an annotation. I have to define here if I can use it just on methods and or on classes. Here I'm just saying I want to have something that I'm able to use only at method level. So I'm saying target is element type method. Then it must be available via runtime. So don't forget this one, otherwise it's just after compile not available. And then there is one thing, this @testable. And @testable is a hack. So I will come to this in a few seconds. And then I want to have one annotation for the test, and I want to have a different annotation on test class, on my test class. Why? Because then I can say on class level, I have the possibility for customizing with attribute A, B, C in my annotation, and on method level, just some other attributes or no attributes. It's just only to show that you can do it differently, and that's it. Okay, what is testable? Testable is a hack. So the JUnit5 team discussed, I think initially with the IntelliJ paper. I'm not sure, there's history, forget it. But right now it is @testable is here, and this is an annotation that could be on type or method level. It is available during runtime, and it's more or less a marker, because the IDE, what they are doing, they don't know if you're creating an annotation for called nanotest or whatever. So to have the whole functionality of the IDE, and this is a generic one, they are just searching for something that includes the annotation @testable. That's it. So don't forget it. If you're adding it and using it immediately, you have more or less 100% IDE support. Writing your own test engine or customizing this one. So I'm creating now my nano engine. It's implementing the test engine, and the ID is just a string. Here I'm lazy, I'm just using the simple name of the class. The next one, I need the possibility to decide if something is a test class, yes or no. And now it's important to know, what do you want to have? A test class, for example, here I say, I want to decide this is a test class if the method is, or the class is not abstract, it's not private, it must be annotated with nano test class, and if this one is successful, it is my test class, otherwise it's not a test class. So it means now you can start defining, if you have special requirements to define this is a valid test class. Later we're doing the same with test method, and to make sure, for example, JUnit5, they are not dealing with return types in test methods. But if you want to make sure that your test is always returning some kind of summary instance, then you could just add it in this predicates we are using later during the discovery process. And then, you know, if I say this is a valid test class, I know there is a return type of class, whatever, type, whatever. Or I have a method signature with input param A, B, or C, whatever. So feel free to be creative and to define what really fits to your project. The same I'm doing with test method, for example. I say it's only a test method if it is not static, it's not private, it's not abstract, and I have no params. So if I have a param, I'm just ignoring with this test engine completely this test method. So even if there's this test annotation, nanotest, but if there's param count higher than 0, I'm just ignoring it. So with this, you can just define the grammar of your test engine and the way how to describe tests. This is a very powerful thing. Do it carefully, because changes here means mostly changes in the whole code base. The discovery process. The discovery process is just going through all input classes you will get. And here it's I'm creating the engine descriptor, the root node of my test plan, and then you have this different selector. So if you're, for example, using the IDE, right click on a package, it will create in the background some kind of selector. And this is different by IDEs. For example, IntelliJ, if I remember right, it's if you're going to a package, it's not giving you a package selector, it's using a class path selector with a filter of this package name. And Eclipse will do it differently, and Maven will do it maybe differently, and so on. So you really have to support all possibilities, and all possibilities is you will get something on class path within selector, you will get something on package level, on class level, or even on method level. Right click on method, execute. And these are the entry points, and from this you have just to think, if I'm starting from root, class root node, then I start going step by step down if I'm starting with package, and so on. So this is just a declaration, boilerplate code we need because there is no support so far from the JUnit5 team. If I want to append tests in root, there's the first method I'm showing here. It's just my selector gets a class path root. I have this one. I find all classes in this class path root, and here you see I'm using this predicate is test class. That's it. So what these service utilities are doing, they're going through the whole class path. One class after another will be provided, and then it will invoke the is class, or this predicate you're just providing. And if this is successful, you will have the class itself. It's filtered. You have just the class that are matching to this predicate is test class, and then you can append this one to your test plan. So, and this append is something you should think about, what kind of information at this level you have and you want to provide later during the execution of your test plan. And the information you're grabbing here, it could be a request somewhere, it could be some static information, whatever, completely free, what you want to have. But in the end, you need the class itself, because this one you need later for invocation and all this stuff. And then you're wrapping all this in some kind of descriptor. And the descriptor is just an extension of the basic descriptors. And then you can add all the attributes you want to hold. And this will then add it to this test plan. And the same with add append in test method. So if you identify it is a test method, then you just grabbing all the information for test methods. I created here this descriptor node for especially for methods, and then put all the information as attribute inside so that this is available during execution, because all nodes in this tree will be delivered step by step, and in the end you have to deal with all information that are available inside this test method descriptor. Okay, all in package. Here I can just say, please use the JUnit5 reflection utils. They are quite good and they found a lot of bugs and it's more or less battle proofed. So use this one, so this reflection support, and then all the static method. Just have a look there. They are providing really a lot of stuff. And here, for example, everything in a package, I just say check my class and then go to every class and add this one. Okay, so if I what's the test plan? So if I'm doing all this stuff, I have a tree, not a graph, a tree, and this is built on the base of test descriptors. A test descriptor is a node inside the test plan, as I mentioned earlier. A node can be a container and a test. So the container for a class is a container, mostly because you have inside test methods. If you have a node for a package, it is a container. The node for a test would be a test. But the tricky thing here is a node can be a container and a test at the same time. Why? I'm not really sure. But normally the test itself is the last point in your tree, the leaf, and the container could be both. So the last thing could be a container as well. So just have it in mind so that you're not losing this one. And a good thing is don't start from scratch from the interfaces they're providing. Start with abstract test descriptor and just using this one as a basic reference implementation to extend this one. Okay, so a test descriptor, extending the abstract test descriptor, and here you just have to deal. If it is a container, you have to have the possibility to add children, and if you are just a test, mostly you don't need this one, and then just going recursive. Here what I'm doing, if there's an invocation of this container instance, this test class or class test descriptor, I'm grabbing all the information from the class itself, and then I start going over all declared methods and creating the child nodes for this one and adding this one. Yeah, that's it. And it's of type container. Okay, for the method it's the same. I'm just holding the method reference, I'm holding the class so that later I'm able to invoke this stuff, because what I have is just class and method and all this stuff, and then I have to invoke what. If you're building your test plan completely independent from some input sources like test files, database, whatever, maybe you have just different informations you need. If you're going here just over plain Java, you need something you can invoke later. Okay. So then the execution. The execution is more or less, you will get some kind of node, and then you have to decide what type of node this one is. And in the moment we have three types. We have the engine descriptor, the root node, we have something on class level, and we have something on method level. If it is an engine, a container one, I'm just start executing a container. Same with the test class, I'm just executing the container. And if I'm finally on method level, I'm executing a method. So it's just recursive down and it's boilerplate code, and there's no other implementation for this, so you have to write all this stuff by yourself. So executing a container is just have in mind, so you have to say I'm starting the execution, I'm executing, and I'm done with the execution. And exactly this is what we're doing here. We're executing this one, saying, okay, I'm this root node, I will start now. Then I'm going to all children, recursively executing this one. And if this is returning back, I'm just saying I'm done. And depending on the result, I say this is successful, yes or no. A method is the same. I just say, now I will start executing the method, then I'm executing the method, and then I'm saying I'm done with the method, positive or negative. And now we are coming to the test method itself, it means in this case I have just a class and the method, so it means I'm creating a new instance. Here you can do everything. You can use CDI, you can whatever you want. You're creating an instance. Then I'm saying, okay, I'm invoking the method here. I'm just using the reflect utils as well. And if you have params, you have to make sure that you're creating the parent instance or the parameter instance by yourself, or just getting by CDI or whatever, and using this for the invocation of the method as well. If everything is good, successful is the return. If it is bad, failed is the result. That's it. So now what we have done is we just went through the whole tree. Here the test engine, just as an overview, out the predicate. This is a test class, this is a test method, and then I'm just discovering everything. So go to whatever selector I'm getting and analyzing all classes and building up the whole tree, the test plan. And after this, I'm just executing here, request get my root node and start executing. So this one is quite easy and straightforward. The main thing is you have to do it by yourself because this one is not provided. One thing here is that you can use service locator here and how to activate this test engine. You have to go to resources, meta and services, and using org.JUnit.platform.engine.TestEngine, and in this file you just full qualified names, adding all test engines you want to execute. That's it. And then you can start writing tests like this one. Add nano test class and inside nano test. Now you can start using your IDE with right click and ramping up, ramping down this stuff and executing and so on. This is a main thing here. Coming now to some ideas. If you are able to build our own test engine now, so we know how to activate this one with the service locator. We know that we need, if you're going over the static semantics, some annotations with this testable annotation inside. We know how to test this test engine with a vintage engine, or Jupyter engine, not the vintage one, the Jupyter engine. Everything's fine, but what can you do with a custom test engine, or what is a good advice to deal with custom test engines or do this one? For example, if you're creating a product, and a product for the TDD world. So for example, you want to have something that you are ramping up, ramping down. Inside your custom test engine, you can, for example, do in the beginning something like a license check. One thing that is not covered by the Jupyter engine is, for example, ramping up something before you're executing all tests, so before you're executing the test plan, and destroying after the whole test plan execution. Right now, you have to deal now with Maven life cycles or whatever, but you can't do it inside the test engine itself. With a custom test engine, you have the full control about the lifecycle. So you're ramping up, for example, your servlet container. If this one is green, you're running all tests and ramping down. With the Jupyter test engine, so far, you can just say before I'm running this test class, I'm ramping up the servlet container and then ramping down the servlet container. This is not so efficient. So you have more possibilities of dealing with the lifecycle. One very interesting thing is that you can control the syntactical behavior or the syntax, how to declare tests. Normally we are writing Java source code and using some dependencies. This is fine, but if you want to make sure, for example, that every test method will give some information about the invocation, you want to collect some information, date, time, CPU usage, but whatever, I have no ideas what you want to have. But then you can collect all this information, give this one as a return type back. If you want to have some parents always injected and make sure that this is always the case, just make this as part of your syntax. If you have to deal with complex life cycles, for example, if you're dealing with web app development, you have, for example, ramping up a database, ramping up the servlet container, ramping up the web driver, executing your test, then for browser A, B, C, ramping down everything in right order. This is it's a big life cycle, and you can really speed it up with custom test engines, make sure that everything is exactly in a way you need it and just invoked as often as you need. One thing is you can deal inside custom test engine very good with authentication and authorization. For example, if you have to consume some services because you have some services that you're integrating in a test behavior, but you have to pay for them, you can make sure that your custom test engine, that this is dealing with credentials, with the maximum amount of requests, with all this stuff. For example, if you have a circuit breaker, you are identifying that the test method is invoking again and again, that you're just shutting down this cost-intensive stuff. One very interesting thing I'm working on is, for example, and I have the first prototypes already done because it's so simple, it's a distributed test execution. So you're running the test engine on your laptop and you're pushing just your piece of code and classes to a cluster. It will be executed there and will come back. For example, web tests are very, very resource intensive and slow, so horizontally scaling is a very good thing. But on test method, for example, level, then you can just write your test, say execute this test. This will be just provisioned inside your cluster and will give you the information back. DevSecOps. DevSecOps is one interesting thing. Normally people are talking about DevOps, and now with DevSecOps, yeah, for sure, security should be something like quality. And it's so easy. If you're already using TDD, integrating security at this level is just the next step. So if you, for example, declaring some dependencies and you're checking, okay, the license is okay, like the scan with X-rays, or adding a dependency and say, okay, license is okay, and there's no security issue and all this stuff. This is not everything. If you want to do something in this direction, think about the security payload generators and the execution of this one. If you have some methods consuming something, just go to a repository, like a generic Artifactory repository, where you're storing immutable all the payloads you want to have as input. So your custom test engine is connecting to your repository, grabbing the security payload, injecting this one, checking if everything is okay or not. And if you have something, a failed test is not enough, it should be reported. For example, if this is on the CI environment, so that you have immediately an alert, there is some special test failing. So stuff like this. And last but not least, security or DevSecOps or whatever, quality. If you want to make sure that everything is reproducible, normally you must store exactly the test plan you are creating. If you're running a few times with reflections on your machine, or on my machine and on the next machine, the test, the order could be different, and the order of the methods, the execution of the method could be different. Normally it should be done like you're creating this test plan, you're dumping this test plan down, for example, to a repository where it's stored with your build number, execution number, person, whatever. So it's part of the build information, so that if you want to recreate this situation, you're not just using the same classes and source code, you're using exactly the same instance of a test plan to have the same behavior. Sometimes you have flaky tests and all this stuff, and quite often it's exactly the point where you should have an eye on if exactly the same test order, or if you have just a slightly different behavior, because you will have different behavior if you're using the same code with IntelliJ and executing there, executing it with Gradle, with Maven, Eclipse, whatever. They are different. So persistent test execution plans is normally what you really should think about. Okay. This is more or less everything what I want to say here at this one. I'm talking a little bit, or I talked about these immutable test plans, because if you're dealing with this one, everything is reproducible. It's part of the security or the quality thing you have in mind. And yeah, that is more or less. If you have any questions, feel free to come back to me via Twitter. I'm available on Twitter mostly. It's the best way to reach out to me. And just ask me, show me some code. I'm more than happy to see what are your thoughts and what's your what you learned with test custom engines so far. Thank you very much, and see you later.
Sven, thank you so much. It was a great talk, and we have a lot of questions. Can I start with my own that I prepared before?
Well, fine.
Many of us well know your colleague Baruch Sadagursky, and my question is, does JFrog force all their developer advocates to wear a hat?
This is a very difficult question. So, are you getting this hat after you're employed, or you must have a hat before you're employed? I don't know the answer, because I had this hat before, so this was not a challenge for me. So I can't give an exact answer.
Okay, thanks. Seva, would you like to ask something?
Yeah. Actually, we have one interesting question. Yeah, hey, Sven. Actually, we have one interesting question.
Unfortunately, we can't hear you.
That's weird. That's weird. Maybe right now you can hear me. Oh,
yeah.
Hey. So we have one interesting question in the chat right now. Is there any way to create test suite analog like in JUnit4 so we can have opportunity to have ordered test suites? We know that we have order annotation, which allows us to manipulate with order itself, but it works with methods, but not with the class. So we don't want to put everything in one class, right? So is there any way, or maybe you have kind of tips around that?
Yeah, it depends what way you're going. If you're going with the default TestEngine from JUnit5, you have this order annotation, you have this possibility of nested classes, and so on. And then you can, I think there's an order annotation, a package. I'm not really sure. So this is changing slightly and improved from version to version. So if you have a new subversion, are working heavily on this sometimes. So if you are with your own test cast or with your own test engine, then you have everything under control. So this is one thing. You can build your own marker if it is part of the static semantics, so like annotations or an attribute inside annotations. You can do it in a priority way, like relative ordering. Or you can do it with explicit numbers. I think something with the explicit order is part of the nested class solution in JUnit5. To say the truth, I'm not really a fan of this strict order because you have to maintain it because people start relying on the order. But on the other side, if you have immutable test plans, and then you have at least always the same order during different test runs. You can group them in test groups. So, and this, again, if you have your custom test engine, then this could be an attribute inside an annotation or a special annotation. And I think something they have in the engine as well. But, well, check what's the latest and what's exactly. So if you start with 5.0 and going to 5.1, and so there are big changes sometimes in exactly those details.
Is there any issues like with nested classes there? Maybe you've heard some of those in this case.
Well, nested classes, it depends what's your what do you like. So some people really like these nested classes. They have one class file and then they have this order, and mostly I saw that they're using it because they like the different output inside the IDE, so this naming schema and this ordering. I'm not a big fan personally of this one. And I think I have one class, a bunch of tests inside. It shouldn't be too big, otherwise I have it's really a personal behavior. So I'm personally not a big fan of this, but I know that some people like it because the way how the test is writing information to the command line or to the reporting. So that's more or less.
Michael, looks like it's your turn.
Yeah, thanks. The question from the chat. It seems that creating our own test engine is a lot of work. Do you think it's feasible to take a standard engine and just wrap it out with our own engine, just adding the things we are missing in the standard engine?
Okay, so I've done exactly the same. I was a lazy bastard, and then I just extended the vintage or the Jupyter engine, and to say the truth, it was a disaster. So using the existing one is good code. So I'm not complaining about the code, but if you want to extend it, it's not a good idea. You have to go in so many details. On the other side, I addressed exactly this boring, repetitive code you have to write with the scanning and all this stuff, and there's an open issue, and they're aware of this. And we wanted to, the idea was to give base class for custom test engines. I have to check the ticket number. And I checked it a few days, and it's still no progress there. So what I'm assuming is it will take some time until they are providing this one, because they have other features with more pressure. On the other side, if someone is interested in making an extension of this, a basic custom test engine, I'm more than happy to join forces, because I have exactly the same. And at the moment, I'm copy-pasting stuff, and this is definitely a bad idea.
So the next question is not actually about the JUnit itself, but probably you know the answer. How to find the balance between creation tools and improving test coverage, especially when you have a big legacy test project? Oh. That's the question from Dennis.
Yeah. So, well, one thing, if you have legacy code, what I really have done a few times, and this was really a money saver, is check out for mutation testing. There is a framework called PID, and I personally gave some talks about it. So, or just come to me and ask. This mutation testing, or this way how mutation test coverage reports are created, they are a little bit time consuming. But if you have just one single test and you're running mutation test coverage about it, then you have a full report of risk. Where is the biggest risk in your code? So in terms of complexity and all this stuff. And if you're using this to decide where you spend your money, if you have just a limited amount of time and resources to start with test coverage, this is the way to go. I know that there are some companies right now working on generated automatic tests, and I had I was in contact with some company from, I think, Oxford. I think it was Oxford. So, and well, it's generating a lot of tests, but the tests, you can see that these tests are generated. So let's say it like this. So I think we need more work on this, or more time, more research. And until now, I would just say create a report, split it up, make a decision based on money, risk, and at what part you're expecting the most changes. And this is the only advice I can give, whatever test method you are using.
Thanks. The next question is, okay, Sven, you persuaded me to create my own test engine. If I want to migrate my JUnit test to JUnit5 with custom engine, what kind of pain can I expect in it?
Yeah. So the JUnit5 team itself had this in mind and built it. the Jupyter and the Vintage engine. The Vintage engine is exactly for running JUnit4 tests inside your JUnit5 environment, but rules are just pain. And the inheritance you had to build with rules because you can just have only extend one rule and all this stuff. So if you're dealing a lot with rules, it will be challenging. With custom test engines, you can use, for example, code generator to build migration codes, or you can just work on the old syntax and re-implementing some features. It depends a little bit how much you customize your JUnit4 stuff. If this is freaking busted, built over 10 years with a lot of extensions, it will be a rewrite. So be careful, make some tests with the ugliest part of your code. And mostly, if it is a very special one, custom test engines are mostly a good way to go because you can just do it in the way you need it. So you have a little bit effort in creating this test engine, but on the other side, you can minimize boring conversion work.
And the next one, thank you. And the next one is about parallel tests. Do you know whether something happens with the context when we run parallel test with custom test engine, or even it's the same? Yeah. Because it's kind of could be painful question for most of us.
It is. So concurrency is never easy. So the implementation, so far I know, from JUnit5, the concurrent runner is based on the common fork and join pool, and means it will just steal exactly those resources, and you have not really a control. You can say concurrency on class or on, I don't know. They have different strategies how to share the amount of tests over different threads. So have a look there at the documentation. Otherwise, if you're running your own custom test engine, you have the full control. So what I've done here is, for example, I really externalize it inside a Hazelcast cluster and use a distributed executor. Or if you're running locally, just make sure that you're isolating the context in a way that fits to you. And this could be done, for example, easiest if every context will create a new UID, and this is used to grab the store you're using as context. So, but it really depends on how aggressively you need concurrency and how long this stuff is living. So where's the trade-off between this concurrency management?
Sven, thank you. As you said, testable is a hack. Should I avoid using it?
Testable. Well, you must use it. Otherwise, your IDE is not supporting it. So that is just, the IDE has a challenge that they don't know how to identify if they're custom, and they need a marker to reference. And this is the only way they were able to agree on. So if you want to use the IDE integration support, you need this annotation in your inheritance.
All right, thank you for your answers, and thank you for your talk. Thank you, Michael, for supporting us with questions and answers from the audience. So I guess that's it for this section, and probably most of you have other questions which could be asked in the discussion zone in the Zoom link below the player. And just a reminder, we will choose one best question. Sven actually will choose this. We can do this in discussion zone, and after that you will receive a prize. Thank you.